Okay, you have been given this model. This model has 4 tables, and you're supposed to implement it, right? So these are entities. They have the names and the attributes, but also we have the foreign keys and primary keys. So there are some questions here that you need to implement. So we are going to do this very fast. But first of all, let us understand the entity relational, the ER diagram and what it means. So we have the DBO, it's the name for the database because it exists in all the entities. Then we have the names of the entities. We have entity, person, student, course, credit. What is listed inside, these are the attributes. And where you see a key, that's a primary key. That's a primary key, and that's a primary key. Okay. But in this table credit, there is no primary key. Yeah. So not all entities have a primary key. Yeah, there are some entities, they're just there as a connector, just trying to connect some two entities. So they don't have to be with an primary key. They can just have foreign keys to enable them connect the two entities. Like this credit is connecting student with the course that they are doing. And if you look at the relationship here, where we are having the primary key, it's 1. Then where we're having the 2 dots, it's many. So that means the person ID will be on this table as a foreign key. Here it's the primary key, it's coming this side. Student ID is here as a foreign key. Then here we have course ID, which on the other side, it comes here as a foreign key. So the relationship between person and student is 1 to many. Between student and credit is 1 to many. Then course to credit is 1 to many. So that's the relationship of this model that you're supposed to use to implement your database system. And so you're being told each query you implement, you have to write, you have to save it on a notepad file. It's very important to do this, especially in an exam setup, because in case of anything, if power goes out, you can always use the notepad configurations to rerun everything and have your data back, just in case you never saved anything. So let's do these questions very fast. The first question is, you are supposed to create a database and you have to name it DBO. Okay, I told you DBO, it's the name of the database. So I will go there to create it very fast. DBMS show databases. I want to confirm it if it's there. It's not there. So let us create that. Create database DBO. Okay, so we have created it. It's here. We have created it successfully. Then we can go ahead and use it. Go into the database DBO. Yeah, then from there we'll look at the next question, which says you're supposed to create the following tables. Yeah, these ones. Then you enforce the necessary relationships, and also you have to populate 5 records in each table. So you see even the marks here, just creating the tables, 8 marks, enforcing the relationships correctly, that is the primary keys and the foreign keys. If you implement them, you'll have those marks. Then populating records on the database also, 4 marks. So we to do this, you just have to start with entity by entity. So at this place, we can start with the person ID to create this table. And in this one, we have to declare person ID as the primary key, and the name of this table is person. So without wasting time, I have the query here. You create table person, and you list all the attributes where we're having person ID, first name, middle, initial, that is the initials of the middle name. We have last name and date of birth. So here you need to be creative because you have not been given the data types for these attributes. So the only thing you have to be creative and determine what data types you will capture there. So you see, like person ID, we are declaring as character 3, it's the primary key. First name, of course, it's a varchar. Middle initial, it's a varchar. Last name, it's a varchar. Date of birth, of course, it's a date. And when writing these queries, you need to know that you create a table, you give it the name, person. Then you open the bracket. After opening the brackets, that's when you start listing the attributes with the data types. Then before you go to the next attribute, you have to put a comma. These are some of the things that if you don't put them, your query will not be executed successfully. Then the last attribute, you don't put a comma, you just close the bracket and terminate. So let us run this and see. So that's the query, we execute it. So it has been executed successfully. We have created the table person. We can describe it, describe person. Yeah, so we see person ID, it's the primary key. That is very important. And you can also, to confirm that the table was, you can show tables to see the lists of the created tables in this database called DBO. We have created table person. So the next table, we are creating the tables first. Then after that, we shall populate the 5 records in each table. So the next table should be student, yeah, where student ID is the primary key. You see the key there. Then person ID, it's the foreign key because you are getting it from this other table, and email. So to implement that, we have it here, table student. You create table student, open the bracket, student ID. You ensure the data type you use here is exactly, no, I mean on the person ID where you're having the foreign key, the data type you use, it should be exact with what you used on the original table. So we are declaring student ID as the primary key, not null. Email, we are giving it a varchar because an email is a string. Then at the end of the day, this is how you implement the foreign keys, where I'm saying foreign key, person ID, reference person. You go even further and declare on delete cascade, on update cascade. I'm putting this so that whenever I delete a record on the parent table, the same thing should happen in the child table. I think I'll be able to demonstrate this later on. It is very important when declaring the foreign keys that you declare on delete cascade and on update cascade. I will show you the importance of that as we go forward. So let us execute this. We execute it very fast. We paste it. Yeah, it's there. It's still there. If you press enter, it has been executed successfully. If you say show tables, we now have two tables. A person table and student table. So we can describe student table so that we check if we have implemented the primary key and the foreign key successfully. So we see the primary key is there. MUL stands for the foreign key. So we have done it successfully. So that's good. So we go to the next table. So from here we cannot go to this one because we have course ID, which is from the other side, which comes here as a foreign key. So we must start where the primary key is first before we come to this one. So let us implement the course table, and we know the course ID will be the primary key. So here it is, create table course ID. I'm giving it 6 characters. Yeah, so you'll be able to see that. You have to note that primary key, name, this is name of the course, voucher, name of the teacher, voucher. So this is a simple table. You can get that. Oh my. Query executed successfully. So we can show tables to see if the table has been created successfully. It's there, table course. Then we can go ahead and describe it. Describe course. So here is our table. We have our primary key as course ID. Yeah, all the data types are there. I think by now you understand what is going on. So let us go and look at the last table will be credit. And in this table, as I told you, there is no primary key. Yeah, because there is no this key. Yeah, this person has a primary key, person ID, student ID, and course ID. But in this table, if you observe, you realize that we don't have a primary key. The only thing we have is the foreign key. So we need to follow that. Yeah, because that means this table doesn't have a primary key. We don't need a primary key because this table acts as a connector. Yeah, like an associative entity connecting these two entities, student and course. So we shall implement it like that, these two as foreign keys. So this is how we do it here, where we create table credit. We list all the attributes first. Yeah, we list all the attributes first there. Let me see the diagram. Yeah, we have student ID, course ID, grade, and attempt. So here, student ID, give it data type, course ID, data type, according to what you did on the where they existed as primary key. Then grade, because here we are capturing the grade, we put it as integer, 3 characters. Then we have attempts. This is the number of times a student did the exam for that particular course. So we are saying only 1 character. That means the only number, the number of attempts can be 0 to 9. Yeah, because 10, those are 2 values. And that means in this column it will not be accepted. Then down here we are declaring student ID and course ID as the foreign key. Yeah, and also we are putting on cascade, on delete, cascade, on update, cascade. When writing these queries, you need to put in mind the opening of brackets, closing of the brackets, and putting the termination, and also putting a comma after every attribute. This is very important. and of course also here, and the last one we are not putting a comma, yeah, because just leaving one comma, this query will not be executed. So let us execute this and see what we shall achieve. Let me see. So we have that, we execute it, it has been executed successfully. We can show tables. So we have our table credit. We can go ahead and describe it, describe credit. So if you observe on this table description, we are declaring student ID and course ID as foreign keys, and they have been implemented successfully. So if you go back to our question here, we have been told to create the following tables. We have done that, and enforce the necessary relationships. We have done that successfully. So the next thing we need to do very fast is to populate 5 records in each table. So that's what we are going to do. So let us do that. So to populate the 5 records in each table, we shall follow the same order. We shall start with the table person, then we go to student, course, then credit table. So we shall start with person, insert into person values, then you list the values as shown. Actually here you need to go by, let me describe that table person. So you'll have to follow the data types here. Yeah, for example, the person ID, 3 characters. We are having 3 characters. Okay, you need to look at that. Middle initial 2. Yeah, we're having 2 here. So in our case here, I'm putting M dot 2 characters. Those are 2. A dot. Those are 2. K dot. Those are 2. Then for date, we know the format for date. We start with year, month, then the day. So this is how we insert data into that. Then you need to be keen on how you write this query for inserting data in tables. We normally insert into name of the table, then values, then you list values for each record. And after each record, the records are being put in brackets, and you put a comma for each record. Then at last you terminate. So let us do that. Let me see. So data has been inserted successfully to table person. To confirm that, we can select star from person. Yeah, so you see our data is here. Person ID, first name, middle name, initial, last name, and date of birth. So the next table will be student. You have to do that. I will move a bit faster now. Here we are inserting 5 records, remember. So insert into student values, they are here, they are just 3 columns. So we do that, we paste, press enter, then we can select star from student to see the data. Yeah, so here is the data, and you observe that the primary key was student ID, the foreign key was person ID, and we are not following the order. Yeah, we're having person number 5, person number 3, 4. There is no need to follow that order there. but here on the student ID it has to follow the order. So for the foreign key, it doesn't have to follow the order. Yeah, when we use the join functionality, you find that it should be able to align these records appropriately in order. Okay, if you observe, let me first select and show you something. Select stuff from person, then select stuff from this student. From student. Okay, so one thing you need to observe here is that person number 1, if you come here to person number 1, the email should match the name. Yeah, it's rose@yahoo.com, because here person number 1, I think this one was inserted wrongly. Let me use person number 3. If you come to person number 3, it's Hadija. Yeah, so the email is Hadija. Okay, so this person number 1, I don't know why it's going with Rose. Where is Rose? Rose is supposed to be 2. Yeah, so that was a mistake. Yeah, it should supposed to match, to rhyme. Yeah, where is the Sonko, Mike Sonko? It is here. So I think I can interchange that. Let me interchange that by dropping drop table. This table is student. I want to drop it. Drop table student cannot drop tables referenced by a foreign key constraint. Okay, it will bring a lot of issues. So let us just leave it at that. Let us proceed. We have cause to insert data into cause. Here is the query, insert into cause values. So let me describe the table first. Cause. I want you to observe on the cause ID, we are having 6 characters. Yeah, that's why here the cause ID is 6. I'm using COU001. That is cause number 1, cause number 2 up to cause number 5. So you need to be careful on the data types that you are using for each column, yeah, or rather for each attribute that you're having. So let us do this. We paste that has been inserted successfully. We can select stuff from cause. So the data is inside. Then we go to next, which is credit. Yeah, you see the attributes there. Actually, the first thing you're supposed to do is describe credit. Yeah, so that you get to know what type of data you are putting for each attribute. Yeah, so if you go here, you'll see that in these two there are integers. We don't have to put them in quotation marks. Yeah, like that. We don't have to do that because it's an integer. Okay, so we have to leave it like that. So it's always good to describe a table first so that you see the data types that are there, so that you know what type of data you're going to insert into. Okay, so we have this, we insert, then we can confirm, can view our data, select star from credit. Yeah, so here is our data. This column shows the number of attempts a student did the exams. This is the grade, the course ID, and the student ID. So we have populated 5 records in each table successfully. So we go to the next question, where you are being asked to write the SQL code to delete the last row on person table. Yeah, the last row on person table. So we can select star. You have to always check from person, then strategize. You check, then strategize on how you delete the last record. So we are going to delete this last record. Okay, so to do that, here's the query: delete from person, where person ID equals to person 05, because this is person 05. Yeah, the question says delete the last row. Okay, the last row, and that is the last row. So we can do that. Refusing to copy. If it refuses, just do it again. Yeah, we have deleted. The query is okay. To confirm that we can view the data in table person, you see now we are left with 4 records. The 5th record has been deleted. So that's how you tackle this query. Then the next one is write the SQL code to change first record on person table. So we are still on person table, first record, that is P01. Okay, so you're being told to write the SQL code to change first record on person table, where you are changing the first name and last name at the same time. Yeah, we need to change first name and last name at the same time. So the query is this one, where you update table person, you list the new values. First name equals to Tom, last name equals to Orengo, where person ID is P01, because that's the question states clearly that we are dealing with the first record. Yeah, so you have to be keen with that. We're dealing with the first record. So if we execute that and view the data, you'll see that first name has been changed from Mike to Tom. Yeah, and last name has been changed from Sonko to Orengo. You see, so that's how you update 2 values in a table at the same time. Then the next will be adding 2 columns on course table, that is course date and course description respectively. Okay, they have not said where, whether it's after or first. Yeah, they have just said we are adding the record, so that means we just add them at the end. Okay, and you have to know the data types. Course date, this is date. Course description, this is voucher. Okay, so to do that, to add the 2 columns at the same time, this is the query. You alter table course, add column, course date, that's the data type. Then the second column, add column, course description, which is voucher, 50 characters. You have to be creative here. Like we are describing, you need 50 characters because you are writing a paragraph. Even you can put it more, to 100 or so. Okay, so that's it. We get that and run the query. So after that, you have to, every time you execute your query, you need to verify if the query did what is expected. Okay, so we will have to view this table course to see the changes. Select star from course. So if you note, we are having 2 columns that have been added at the end. Yeah, actually you can go and check also the data types for these two columns. So we can describe course, yeah, and you see course date, the data type is date. Course description, the data type is voucher. Okay, that's good. Then the next will be write a query to count the number of courses available. So that means here we are dealing with if you come and see show tables, where are we having courses? Yeah, we are having courses in course table. Okay, so we can view the data and see, select stuff from course. Yeah, if you look at it, we have name for courses here, so we need to count and know how many they are. So a simple query for that, to achieve that, is select do I have that? Yeah, I think it's here, where you are selecting count as select count all, and let it says as available courses from course. So that's the syntax. That's the syntax. So it brings here available courses are 5, and if you count them, they are 1, 2, 3, 4, 5. Okay, those are the available courses. Then next we have write the query that will list both first name, last name, and their ages from person table. So we need here, let me display data in person table, select stuff from person. From person, you'll be able to see we've been told to select first name, last name, and age, but we don't have a column for age. That means we have to use date of birth. Yeah, to create a derived attribute, we have to calculate the age for these persons. Okay, so the query to do this is this one, where you are selecting, let me maximize it, where you are selecting first name column, last name column. Then for the age, we need to do the derives, where we are saying year, current timestamp, that is the current year. Then we are subtracting the year, which is their date of birth, yeah, as age, so that we get their age. And we are doing this from table person. So we will get that. We'll get that and put it there. If you execute it, you see it brings beautifully first name column, last name column, and age column. Okay, so that's the beauty of this SQL query. And that was the last question. But before we finish, I wanted to show you something. Remember, we deleted one column here, yeah, and which is record 5. And you remember when we are declaring the foreign key on this side, we said on delete cascade and on update cascade. So we need to see if there is an effect. We deleted a record here. Was that record related to this other side deleted also? So we need to go and check that. So we'll start with select star from person first. Yeah, before we had 5 records, but now we have 4. So we need to check also on student table what is happening there. So we select star from student table. Yeah, are you observing what I'm seeing? Yeah, we deleted P05 on this particular table. If you come and look here on person ID, P05 record has been deleted also. We are having only 4 records left, yeah, and we had put 5. Only 4 are left. So are you seeing the importance of putting on cascade, on delete cascade, on update cascade? Yeah, we can also try and check on the next table, that is credit table. If it has an effect there, select stuff from credit. Yeah, you see it has affected all the tables. Yeah, one record has been deleted. We have only 4. Yeah, let's try also with our last table, which is cause. If I think that one has no effect, maybe, I don't know. Select star from cause. Yes, this one has not been affected. All 5 records are there because it is not connected to this first table, but there is a connection between first and the second and third table. Because here there is no primary key connecting to this side, this table has not been affected. So these 3 tables have been affected because of on delete cascade, on update cascade. So I think you have seen the importance of putting that. It helps us avoid redundancy or having irrelevant data in our tables. Yeah, because whatever data you have in the table, it's data that is sensible and understandable. Yeah, also the data here, we have no redundancy. All data is structured well. So this is how you tackle these questions. I hope you have understood. All the best.